We've been talking about the benefits of automated testing for a few episodes now. Automated testing can be amazing. It can be lightweight, it can be fun, it can dramatically improve the speed of your project, the quality of your code, and your ability to consistently and reliably meet ever-changing requirements. Today, we're going to talk about how you can actually achieve those goals in practice. And it's going to be a little bit surprising. I'm going to tell you, stop doing unit testing. Don't do unit testing, don't do integration testing, and don't do system end-to-end testing. These concepts have been part of our industry for decades, and although they are not bad, they are all fraught with peril and often lead to the scenarios where we all hate to work with automated testing. I'm going to give you a new idea today, and that idea is called modular testing. Let's get into it. Hello, I'm Shane Brinkman Davis Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. And today, we're going to talk about how to actually get all those great benefits from automated testing.
I think that you should not do unit testing. I think you should stop doing integration testing, and I think you should stop doing end-to-end testing. I think these three concepts have pervaded our industry for quite a while now, and they seem so simple and obvious that we just keep repeating the mistake of these three levels of testing. But in reality, I think that they are very poorly tuned, and they tend to result in problems. Unit testing is certainly the easiest to jump into. I've certainly been an advocate of saying, just get unit testing done if nothing else. At least you'll have some basic tests. Your code will be exercised. You'll catch a lot of basic errors. What I didn't realize is that when I said unit testing, I was not meaning the same kind of unit testing as other people. I realized the way I do testing isn't really unit testing. It's just as easy as other people's unit testing, but it is fundamentally different. And we'll talk about why in a moment. But let's now talk about why current unit testing is kind of sucky. Current unit testing has this problem. It's great that it's easy. And current unit testing kind of looks like you look at every single function in your code and you write a suite of 1 to a dozen tests for that one function where you test every possible input, you test every possible edge case, you test every possible invalid input, and you make sure that it does the right thing under all those circumstances. That's what I would call unit testing. If you're doing this properly, your testing is going to be multiples of sizes larger than your code, because your functions should be small for good functional design. And then your tests are going to be at least as big as your function, if not bigger. And you're going to have a dozen of them per function. So almost immediately, you got way more testing code than you have source code. We've already lost coding time in our project by adding tests. Let's go look at integration testing. What does integration testing look like? I switched to starting to say, oh, I guess what I do is integration testing if I'm not doing unit testing, because I don't go and test every single function. So I must be doing integration testing because I'm integrating multiple things together. The thing is, I think when the industry talks about integration testing, what they usually mean is testing two different major components, that are in some sense physically separate in your system. They might be two different repos, two different modules that are in two different code repos, and you're testing how they interact with each other. This is a really big, chunky operation and really, really hard to automate in the reliable way. Certainly, how these larger components can interact with each other is really important. But the problem with integration testing is not so much that you're testing integrations, but that it doesn't give you any guidance. And this is also the problem with unit testing, but it shows up more with integration testing. What do you test? What do you integrate? What components do you test working together versus which ones do you not test? Because it's not system testing, it's not end-to-end testing. You're only testing some of the components. But integration testing doesn't give you any guidance other than you should take two things that are separate and test them together. That's all it tells you. It becomes pretty hard to figure out what a good strategy is there. Quite often teams get into the weeds with integration testing and they just start testing everything. Once again, we start to go off the deep end of having too many tests because we're trying to strive for this imaginary perfection goal. I have definitely heard developers say there's no such thing as too safe. There's no such thing as too many tests. No, that is not true. There's no such thing as perfection. There's only a requirement. For many systems, 99% accurate is totally fine. Some you need to do 3 nines, 99.9. The best systems are only going to be 4, 5, or most 6 nines. And 6 is crazy, but none of them are perfect. And none of them are 100%. Then we go up to systems testing, and system testing is obviously the grand poobah, where you're trying to test everything all at once as realistic as possible. I largely don't like systems testing because I think it just sucks. I think that it just sucks. And it sucks because it's really slow. It's really hard to set up. It's really unstable. And system tests are breaking more often just because of the test framework is breaking than because of your actual code. And if they fail, they don't tell you much about what's going on. I think the right way to think about systems testing is it's kind of a canary in the coal mine scenario. You want it to be pretty light at that level. You want to catch the errors at a lower level, because if it fails in end-to-end testing, it's going to be nearly impossible to debug at that level. What it's going to tell you is I don't have sufficient tests at the lower level, and I need to go write tests at the lower level to catch this error. Again, it's a canary in a coal mine. It's a real world scenario. You want to see if all the things work together. Yes, I think that that can be beneficial. I do think it's the last thing to automate. If you have not launched your product, like an actual launch, not even a beta, if you have not done an actual launch, you probably don't need end-to-end testing. If you're a big company, you're doing a big launch, you can see that. But if you are a startup, do not do end-to-end testing until you have a V1 that is thriving out in the wild and has growth. Instead, maybe write a script that you can walk through of testing the end-to-end happy path with your staging server. Your staging server is already an integration system, and then you can do a walkthrough, do it manually. This comes back to the broad thing we should keep in mind with all testing. Do not automate what does not speed you up. Let me say that again. Do not automate what does not speed you up. Only automate what's going to speed you up. How do you know that? You automate something you are doing repeatedly already. If you're starting to do something over and over and it's becoming obvious that it's a repetitive thing, then you automate. All testing really should follow that rule. You're doing manual testing, Oh, now we should put some automation around this so we don't have to manually test it. Now I can shift gears and we can talk about modular testing.
All right, so we've talked about how we should stop doing unit testing, integration testing, and end-to-end testing. We should be doing something different. We should be doing something that only takes 10 to 30% more time to create and maintain compared to our main code base. Then hopefully we will reap the rewards of overall net accelerating our process instead of our code becoming half the speed, 3/4 slower, 90% slower as it grows. If we have a good and lean test suite, then we can keep our code velocity high, and it only costs us 10% extra. We only get that if the test suite doesn't get too big itself, because if the test suite gets big, then it itself becomes unagile. So here is what we're going to do. We're not going to do unit testing. We're not going to do integration testing. What are we going to do then? We're going to do what I call modular testing. And all of a sudden, for anyone who has listened to previous episodes on Code and Optimism, you should have some light bulbs going off. Oh, right. Modular design is the fundamental building block of good software engineering. Good modular design and the 5 essential elements of good modular design allow you to manage complexity as your complexity fighting superpower. I'm going to highly recommend you go and watch some of those earlier videos, but we will just very quickly talk about the 5 essential elements because it's important to remember them. I've got an acronym I have been using recently called PIECI, P-I-E-C-I. First, a module needs to have a clear purpose. This is a stated purpose for the humans to understand why this thing exists in the first place. This is very much a Simon Sinek start with why. Why does this module exist? Why is it important? Why does it serve the real world in a meaningful way? This is going to guide all the rest of your decisions about this module. The better your purpose is defined, the better your module will be. The worse your purpose is defined, the worse your module will be. For example, a utilities module has basically no purpose other than to put a bunch of things in one place. It's the junk drawer of modules. Saying that, that's also where all good modules begin. Modules don't just come out of nowhere, they grow out of existing code. And many good modules start out of a junk drawer. Next is interface. It's not surprising when you think about a module, usually it has an interface, it has an API. And that interface should be defined in terms of the purpose of that module. It is going to be the external facing part of the module that allows that module to service its goal, its purpose. Then we have encapsulation. Encapsulation is really where we get our complexity fighting superpower. It is drawing a very hard line between the implementation inside the module and the interface to the outside world. Those 3 things together are the essence of an individual module and how to make an individual module good. I have seen encapsulation go very awry. There's the problem of a thin veneer module, where you make a thin API that just talks straight to the encapsulation and does very little abstraction from the implementation to the outside world. In which case, any change to anything on the inside requires a change to the API, which requires a change to the clients. In which case, you kind of lost the whole point of making it a module. On the other hand, you could have such a high-level interface that it's really just like, do it, as the outside interface. In which case, there's no structure on the outside of that module. The module is just a red button. You have really just drawn a big circle around your whole system for no net benefit. There is a sweet spot where you have an API which is just sufficient enough to be powerful and flexible and serves a purpose, but it is not directly connected to the implementation, and that the implementation is fairly free to change underneath that interface. So that's the PIE. CI is for connection and implementation. Connection is no module is an island. Every module is within a network of other modules. A module will be leveraging submodules, and every module itself will be a submodule of other modules. As you're deciding what goes in what module, you're actually looking at an ecosystem of modules. So not only are you trying to get the maximum benefit of a lean, small interface to a well-abstracted encapsulation, but you also want the interdependency between all these modules to be minimized. You want to have the minimum amount of interdependency between modules so that you can have the maximum flexibility to reconfigure the system over time under changing requirements. Implementation is the very last one, and it really is just a nod to all other engineering. No matter how good you do all the rest of this conceptual architectural design work of the module, if the implementation is sucky, the module is still gonna suck. If it's underperformant, if it's buggy, if it's unreliable, it's gonna suck. And of course, that's why we're gonna do some automated testing, because we're gonna try to make sure that implementation is good. That's modular design. The key thing is complexity normally scales exponentially with code size. You just take the size of your code. I think tokens is the best way to measure it, but lines of code is a good enough substitute, and square that. You double the size of your code, you quadruple the complexity. If you 10x your code, then you're 100xing your complexity, and it gets out of control really fast. The only way to manage this is through good modularity. Modular design is the superpower in writing software. So it should come as no surprise that the superpower to writing good tests is modular testing. Here's how it's different. Here's what is significant. It actually parallels unit integration and system testing, but it's also perpendicular. It just takes that whole thing, which is kind of a 2D perspective on testing, and brings a third dimension into it: purpose. Modular testing says just one thing: only test from the outside, only test the API. That's it. That's modular testing. Okay, I'm done. See you guys later. I'm so glad I was able to share it with you today. I hope that you love that insight. Yeah, this is one of those things that is easy to explain and difficult to master. But that is true. This is what the definition is: only test from the outside. Take your modules, do not test the insides of your modules. Do not test the implementation directly. Only test through the API to your module. All tests have to go through your API. And if you do this, then you reap the same kind of superpower rewards you get from good modular design. For a very obvious thing, you can now change your implementation arbitrarily as long as it does not change the interface. You can change the implementation any way you want, and it will not break your tests. You won't have to change your tests. And your tests will be valid and good tests for all those changes in that implementation. Now, if you're unit testing every single function inside that module, and you've got 10 times as much tests as you do actual code, if you refactor the inside of that module, you're gonna refactor 10 times as much code to refactor all those tests. If you're only testing from the outside of the module, you refactor all that code, you have 0 test update. More generally, it brings a lot of cool benefits. It brings the benefit of, if your tests fail, because your tests are only testing the API, if your tests fail, that means you've broken the API. Now, all of a sudden, your test suite is now a signal to whether or not you are creating major version changes in your API. That's really important to catch whether or not you had a major version change and didn't know it. Or if your code actually broke something that it shouldn't have broken, then you have to fix it. Again, your tests did what they should do. They're testing whether or not you have correctness, which is a huge win. Further, if you are adding new functionality, this is when you will need to add new tests. And it'll be very clear that you need to add new tests because you're now exposing new things to the API that need to be tested. When you look at your coverage report, you will see all your new stuff isn't getting covered at all because it doesn't have the test for it until you start adding those new tests. Similarly, speaking of coverage, if you look at your coverage report and you see code that's never getting touched and you can't seem to get to that code through the API, Well, you probably just discovered dead code. So this also becomes a very straightforward way to detect dead code in your system that you can delete and remove. Further, this is very strongly SEMVer aligned in the semantic versioning space. So patch changes, minor changes, major changes. This is just reiterating on the concept we've been thinking about, but think about it from the perspective of, as you're developing modules and releasing them into the world, the better you can get at making sure your semantic versioning lines up with what's actually happening in your code, the more it's going to work pleasantly within the rest of your modular ecosystem. If you're making patch changes, it doesn't change the API at all, in which case your tests should just work. Now your patch changes might be fixing a bug. You should follow red-green testing, which is just a little aside, but red-green testing means if you have a bug, your first job is to write a test that reliably reproduces that bug. That is a red test because it'll be failing because you haven't fixed it yet. Then you go in and you fix the bug, and then the test becomes green. Now you've added that to your test suite because you discovered your test suite was inadequate. If your test suite is succeeding, but you have a bug, that means your test suite's inadequate and you should add a test. That's how patch testing works in the system. We already talked a bit about how minor changes work within the system, in that you will add new code and it will not be covered in your coverage reports, and therefore it'll be clear you need to add tests to capture that new functionality. We also talked about major changes because you change the code and it should break your tests. If it doesn't break your tests, it means that you have inadequate testing. That's another sign to learn how to do your testing better, but it should break your code. Then you go fix your tests, and then you have a clear statement of what the new correct API is for this new version. How does this fit into the unit testing, integration testing, systems testing universe? For unit testing, this really is super easy, just like unit testing. But you're basically doing the unit testing at the API level rather than individual functions. And it still can be just about as easy as those unit tests, but you only need to make it as big as your API. Your API ideally should be 1 to 10% the size of your implementation. So if roughly speaking, if we count the number of API endpoints and the number of functions in your code, it should be between 1 to 10%. You should write your tests like you would much write unit tests, but you're using the API function call endpoints rather than those internal functions calls. Further, when you're writing these tests, you're going to write these tests using the API. You should be writing your tests to demonstrate how the API should be used or how it should not be used. You might be testing error cases and so forth. That creates the best form of documentation because it documents how the system works from the outside. That's the external requirements, the external ways it works. The people who are going to use this module can look at your tests and see examples of how to use it correctly or how to use it incorrectly that are real and get updated. So it hits that surprising benefit, as we talked about in previous episodes, of getting better documentation. We've also touched on the code acceleration aspect. It requires very light maintenance to keep one of these test suites going. Let's talk briefly about how it makes your code better. You're testing from the API. As you're testing from the API, you will discover that your API is a pain in the ass to use. Or you'll discover that you did a good job. But you might realize writing tests against this API is a pain in the ass. And in doing so, you will realize that you should make a better API. If you're doing this while you're developing the API, if you're doing it during development, which is how you should do your testing, then you can actually make these improvements to the API before it becomes public, before other people become dependent upon it. All of these benefits, as you're paying attention to them, will drive you to better and better modular design. You will realize, oh, I don't have a strong enough abstraction. I don't have a strong enough purpose. I don't have a clear enough interface. I don't have a good enough implementation. All of those PyCI things are exposed very strongly because you're writing everything from the modular perspective, from the client's perspective. It's kind of like unit testing, but you're going to write these tests kind of like integration testing also. I find the best way to do this is do the user scenarios. Take the user scenarios that you and your product people, or you and your architect, or if you are the architect, you have thought through, here's the way this module is going to get used. And it won't be used with just one function call typically, although sometimes that is it, but often it'll be a sequence of function calls. So you will write your tests to tell those stories. This is a typical way that you would use it. You would do this, then this, then this, then this. You'll write your tests that way too. In fact, that's why I invented the Art chained test testing library, which in JavaScript works with Mocha and works with Jest. It allows you to write test, 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 but instead of test, 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 you say test, dot, then test, dot, then test, dot, then test. So it allows you to have separate little bits of tests, but they will be guaranteed to run sequentially. So you can do a sequence of tests. You can skip tests and other things, and it does all the right stuff. You can do these larger sequence of tests. You can test more real world scenarios. But you can also do it in a way where you can run individual little tests as efficiently as possible. If you don't have a chain test suite, it's still fine. You can still do the same thing effectively by making little testing libraries and other things that group together common sequences so you can run those sequences easily within each of your individual tests. Of course, you'll do the happy path stories, you'll do the sad path stories, you'll do the error paths that you are intending to handle well stories, and you'll do the crazy things as well. All of these demonstrate how the thing should be used from the outside. All of these essentially are testing the overall integration of your entire module. But wait, your module is probably dependent on other modules. If you're testing your module, it's got to, by definition, be using those other modules to fulfill its purpose. You're naturally doing integration testing across modules. You didn't even try. You're just writing against your API, and all of a sudden you're getting all this integration testing for free. Now, of course, there are external modules which are actually external web services, or they are another module in your system which is remote. When you're running your tests, it's generally good to not be dependent on external calls that could fail without your system being wrong. You shouldn't test other people's modules inside your module. You do want to test how you're interacting with that other system and you're making sure that you're doing it correctly, because you may not. And so you want to have a fairly realistic connection. This is where mocking comes in, which I used to call mocking a code smell. And I do largely think it's a code smell. I think that's largely because it's often done wrong. Oh, we'll just mock everything. Mocking has two big knocks against it. One, it's a lot of extra code to write. Two, it makes your actual source code more complicated often because you have to actually put in places you can insert mocks into the system. The worst one against it is if that mock doesn't accurately reflect how that other service works, then you aren't actually testing a realistic integration with that service. If you're testing against external services, you have to make some intelligent decisions about how much am I going to mock that service, how much am I going to test against it, what am I going to test, what am I not going to test. But I find as long as you have that perspective of I want it to be as realistic as possible against that other service, you can usually mock it at a reasonable level. You can do a little bit of low-level testing that tests a couple calls that actually hit that service or hit a mock that's very close to that service. But then you can ratchet up your mock inside your code to be a slightly higher level that more is tested with the logic of your module rather than the logic of that service. You can say, all right, I'm going to assume that that service is correctly. I'm going to assume my low-level library talking to that service is correct because they have their own tests. I'm going to just test my higher level of one call up from that in my code that's talking to that service. I'm going to test it at that level, and I'm going to mock that because I know how it's supposed to work, because that's my code. I know how that's supposed to work. I can make a mock that's realistic. And usually, at that point, your mock should look much like your normal code. In fact, it probably should be your normal code, just in a slightly altered mode. Then you're not dealing with the problem where your mocks are a whole bunch of code that aren't really tested. They're just there. Hopefully that they're doing the right thing, but you don't really know. If your mock is largely based on real code, just running in a slightly different mode, then you have a lot more confident that you're testing stuff that matters. So you're getting natural integration automatically without almost any effort. You're getting natural unit testing because it's just as easy as unit testing because you're just testing individual function calls, really. And then what about system testing? Ultimately, system testing is just modular testing at the highest level. So it's all modular testing, all the way down and all the way up. It is modular testing down to your base modules, and then your modules that stand on top of those, the modules stand on top of those, until eventually you've got your whole system, which is also just a module. It has an external API that talks to the rest of the world. The rest of the world might be humans. As I said before, system testing can often be more pain than it's worth. And that's really my offer here is, yes, we can do that, but almost by definition, whatever we're building is going to be at the limit of our ability to manage it. If it was trivial to manage, it'd be trivial for anyone to write this code and we wouldn't be bothering. It's going to be at the edge of our ability to manage it. And therefore, at the systems integration level, that's going to be at the limit of our ability to automate. And so I think I should take a hard look at, does it make more sense to do more traditional QA scripting at that level until we really understand really well how to run that system to the point where we can go, okay, now I know how to automate it. And if I automate it, it'll save time. It'll now save us QA time because we are been doing this manual QA script every time, and it makes our deploys take an hour every week. And maybe there's even like 3 people involved, so call it 3 hours a week. That's still only 150 hours a year. How much time would it take for you to automate that suite? Would you be able to do it in 150 hours? Often with an end-to-end system testing, the cost can be that high. So it still may be better just to keep with the manual test suite. I think modular testing just shifts the way you think about things, and it shifts you into the mode where you get, I think by definition, maximum benefit from testing. I don't think there is a way to actually get better benefit testing because modular design is the essential and only way to manage complexity as you scale up building software projects. Modular testing is also, by definition, the ideal way to scale up. Now, I say that with a strong and confident voice, but you know me, I don't believe there's anything as 100% truth. There's exactly 100% truth, and that is the entirety of the universe. Anything less than the entirety of the universe is necessarily not 100% truth. So there is something I missed. There's a way to do it better. There's something I don't fully understand, and that's great. It means there's always an opportunity to do better, always an opportunity to level up. I would be curious if you buy my basic premise, but if you have some interesting nuance to give back to me to think about how this applies in your scenarios. How can we learn to level this up and do it better? How can we do testing that only takes approximately 10% more effort at coding time and still gets all those benefits of exponentially improving our long-term performance because our code base doesn't slow down by 9/10 over the long term, but still allows us to ensure we meet requirements over time as quickly as possible. Thank you for spending your valuable time with me, and remember, all problems are solvable with enough knowledge.